Welcome to this video. In the previous video, we learned about similarity of triangles, proportionality of triangles, and basic proportionality theorem. Today, we will look at some interesting examples based on it. Nakul was standing below a pole built in his school. The length of his shadow was 4 feet, and the length of the shadow of the pole was 7 feet. He sees that the lines connecting the ends of the two shadows at their maximum heights were parallel to each other. If the height of Nakul is 5 feet, then find the height of the pole. Can you find this? You may think that it is not possible to do this without a ladder and a scale. But solving this and such similar questions becomes easy with the help of basic proportionality theorem. If you observe carefully, you will notice two triangles, ABC and DBE here, in which AC and DE are parallel to each other, where AC and DE are the lines connecting the ends of the shadows of Nakul and the pole to their maximum height. We assume that the height of the pole to be x, which we have to find out. BE is the height of Nakul, BC is the height of the pole, DB is the shadow of Nakul, and AB is the shadow of the pole. Looking at this picture, we can say that line DE intersects the sides AB and BC of the triangle ABC at points D and E respectively, which is parallel to the third side AC of triangle ABC. Can you find the value of x? For this, we can use the basic proportionality theorem, according to which if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. In this triangle, sides AC and DE are parallel. Hence, the ratio of BE and EC would be equal to the ratio of BD and DA. Now, we substitute all the values. Can you now think of a method to find the value of DA? You can find the value of DA as follows. Substituting this value of dA, we get x is equal to 8.75. Therefore, the height of the pole would be 8.75 feet. In this example, you saw how we can use the basic proportionality theorem in our day-to-day life as well. Let's look at another example. With the help of this figure, prove that in triangle XYZ, lines YZ and MP are parallel to each other. What can you tell by looking at the figure? The similar arrow marks in the figure indicate that these lines are mutually parallel. We have been asked to prove that the lines YZ and MP are parallel. How can we prove this? If we observe the triangle XOY, we get to know that the line MN is parallel to the line YO. Hence, according to the basic proportionality theorem, XM by MY equals XN by NO, which is represented by equation 1. Similarly, we can derive equation 2 from the triangle XOZ. From equation 1 and 2, we get XM by MY equals XP by PZ, which we represent by equation 3. Now if we look at triangle XYZ, with the help of equation 3, we can say that the line MP divides the sides XY and XZ in the same ratio. Hence, according to the converse of basic proportionality theorem, we can say lines MP and YZ are parallel to each other. Today, in this video, We saw examples based on basic proportionality theorem.